Hi students, I am Dr.R.S.R. Naidu. Today we are going to discuss the course on power electronics, and the topic is basic theory of operation. At the end of this session, you will be able to explain the applications of the power electronic devices. So what are the power electronic devices and all we can discuss. And also you can be able to explain the characteristics of the power semiconductor devices. And also you will be able to classify the power electronic circuits. So coming to the overview of this today's instruction. First, we will go to introduce the basic power electronic devices. What are the basic power electronic devices like diode, transistor, SCRs, MOSFETs, and IGBTs? All these, the basic power electronic devices can be introduced in this session. And then after discussion of all the power electronic devices, we will concentrate on the silicon controlled rectifiers. That's simply it's called SCR, silicon controlled rectifiers. And then we are going to learn about the characteristics of MOSFET and IGBTs. MOSFETs and IGBTs. Then we are going to explain the basic theory of operation of the silicon controlled rectifiers. Then static VI characteristics of an SCR. What are the static VI characteristics? We will learn in the coming sessions. Then turn on and turn off methods of an SCR, silicon controlled rectifier. Dynamic characteristics of an SCR. So these two are very important. Static characteristics and the dynamic characteristics of an SCR. Then what is a snubber circuit and the design of a snubber circuit. Then finally we would like to introduce about the basic requirements of gating circuits for SCR, IGBT, and MOSFET. So this is the overview. This is the overview of this course. Then let me introduce the block diagram of power electronics. So this is the standard block diagram of power electronic devices. In this is the supply point. We are giving the power supply. This is called an input power input. It is represented with the input voltage and input current. These are giving to the power processor. See, this is the power processor. So this power processor is also known as power modulator, power electronic modulator. This power electronic modulator will convert this available input power supply into desired output, which is feeding to the load. That is feeding to the load. So let us say if you have an AC source here and your load is requiring a DC source. So then this power modulator, this power processor or power modulator will convert this AC into DC, AC into DC. Then that DC is feeding to the load. That is the purpose of the power processor. In vice versa also applicable. If you have an DC supply here, DC supply voltage, and you have AC load, then you cannot give DC to the AC load. Then again, this power processor or power electronic modulator will convert this DC into AC. So this is the purpose of power processor. Then you need to measure the output parameters. You need to measure the output parameter, whatever the output you are converting by using power processor, that you have to sense and send to the or feeding back to a controller. This is the controller unit. This is the controller unit, and this controller unit will also feed it by one reference signal. This is the reference signal. This is reference signal feeding to the controller. Now the now this controller will compare the reference signal with the feedback signal. Then it will generate some commanding signals, also called control signals. So this is what. So this controller will generate the control signals or command signals to power processor unit. Accordingly, the power processor unit will operate. So this is the complete block diagram of power electronic devices. So once again, let me repeat this. This power processor or power electronic modulator will convert the input supply into desired output to be given to the load. This desired output will be feeding back to the controller. This controller will compare this feedback signal with a reference signal and will generate a command signal, or also called control signal, to the power processor. Accordingly, the power processor will turning on and turning off. So that is the concept. So the next thing is that power electronic applications. So what are the applications where you will find the power electronic applications of power electronics? These are very important. The first thing is that the power electronics you can find in your residential applications, like the first thing that you can remember, that is inverter. Inverter is a beautiful example of power electronic. What it does, the inverter, it can convert the DC to AC. And then these are the domestic inverters. Industrial inverters, that is like the 3-phase inverters, also you can find in commercial inverters or commercial power electronic applications. And then industrial power electronic applications, transportation, like electrical vehicles, okay, utility systems, like in power generating systems and distribution systems, aerospace applications, telecommunication systems, wherever. So without power electronics, nothing is there. Now a precise controlling, sensings, conversion of the power supplies, all these things can be possible with power electronics devices. So all the areas are frequently using the power electronics applications. Then let me give you interdisciplinary nature of power electronics. So what are the subjects that are giving you an insight of power electronics? So if you see this, circuit theory, systems and control theory, signals processing, electronics, micromagnetics, power systems, power electric machines, simulation and computing, solid state physics. So all these subjects will, you have to go through these subjects so that the fundamentals will will comes from these subjects to understand the power electronics. And also we can say that the power electronics is an interdisciplinary subject. So all these subjects we have already come across, so that in order to better understand, we have to um, get a good amount of knowledge from these subjects. So, and then we can see the types of power electronic circuits, as we have said. First one is diode rectifier. So what is diode rectifier? So you can draw the a diode. You can draw the diode here, the symbol of the diode here. Okay. If you see here, this is the anode. This is the anode, and this is the cathode. This is the anode, and this is the cathode. So this is the symbol of the diode. What it will do, the diode will convert from AC to DC, AC to DC. That's why it is called diode bridge rectifier or diode rectifiers. Diodes are majorly treated as a rectifier switches. How it will convert and all these things we can explain later. And then after, AC to DC converters. AC to DC converters, in this, if you see this box is a converter. If this box is converts from AC input voltage, if you give an AC input voltage, and it will get if you get the output voltage as DC, then you can call this box as phase controlled rectifiers. Phase controlled rectifiers. So if the any converter converts from AC to DC, then that converter is called as phase controlled rectifier. And then DC to AC, DC to DC converters. So if your input is DC, if your input is DC and output is also a DC, then that converter is called a chopper, DC choppers. So if your input is AC and output is DC, then your controller is called an rectifier. Controller is called rectifier. And if your input is DC and output is also DC, then it's called chopper. So the next thing is DC to AC, and then similarly AC to AC. Okay. So these are the names. If your input is DC and output is AC, then that is called in inverters, which are mostly used in every households. And if your input is AC and output is also AC, then your converter is known as cyclo converters. Very, very important. So these names you need to remember. So AC to DC, that's called an rectifier. 1 second, and I will tell you. If your input is AC and output is DC, that's called phase control rectifiers. And if your input is DC and output is also a DC, that's called a choppers. And if your input is DC and output is a AC, then the rectifier is called an inverter. You know, that converter is called an inverter. If your input is AC and output is also AC, then your device is known as cyclo converters. So these are the types of power electronic converters. So like this, we have designed this session. Majorly, we have discussed from the starting point. Okay, and if you see here, now we have discussed about the applications. We have discussed about the applications of the power electronic devices. Like in the domestic applications, industrial applications, commercial applications, aerospace applications. And also we need to see the characteristics of the various power semiconductors, and we have seen the classification of the power electronic circuits, and also we have seen the classification of the power electronic circuits, how the power electronic circuits are classified, and also we have seen the interdisciplinary nature of the power electronics. Okay, the types of power electronic circuits. Thank you. In the next session, we can go for the characteristics of the power electronics devices, basic power electronic devices. Thank you all. Thank you very much.